Now that we've learned how to talk about forces, and we know that there are balanced forces or net forces, we can start to do some calculations with force. So remember that all objects have some forces acting on them. We have friction that resists movement. We have gravity always acting on everything. Okay, and then you can have pulling forces, kicking forces, pushing forces, all of those different things. So now let's incorporate that into some example ideas and look at how we can calculate these. So this is going to deal with Newton's second law of motion, and it's going to be that equation that we got introduced to back when we first studied Newton's laws. Okay, so here is his equation for the second law. Force equals mass times acceleration. Okay, and there's your units there. So force is going to be measured in newtons. Okay, so that's a capital N. So that's all you need to write for your unit is a capital N when you're calculating force. You have mass, which is kilograms. Then you have acceleration, which is meters per second squared. Okay, so for those of you who like to keep up with your units and you follow through with the units, 1 Newton is equal to 1 kilogram meter per second squared. Okay, since it's kilograms times meters per second squared, that's your full unit for a Newton. Okay, that's your full unit for force. So if you were to write that as a unit, that would also be correct, or you could just write the capital N for Newton as that derived unit. Okay, so that's up to you. So there's our equation. Go ahead and add this to your equation sheet. And then here's how it fits into the triangle for those of you enjoying the triangle method of calculating. So let's do an example problem where we need to use this equation. What force would be required to accelerate 40 kilogram mass by 4 meters per second squared? So just like always, let's break this out. What do we know? What do we need to know? Okay, so the first thing it says is what force would be required? So I know I need to calculate force. That's my unknown. We have a mass. It is 40 kilograms. And we have an acceleration, 4 meters per second squared. Okay, and so I know that these are where they go based on those units. So just keeping up with those units. I know that kilograms are for mass. I know that acceleration is always meters per second. So that's how I know where they go. Okay, so I have force, I have mass, I have acceleration. So I look at my equation sheet and I see what kind of equation do I have that has these factors. And that's my force equation. Here's my triangle. Force equals mass times acceleration. Okay, my force is my unknown, so let's cover that up. And so that means I need to do mass times acceleration. Okay, just plug in my numbers and then calculate. So 40 times 4 equals 160. And then I'm going to use my derived unit, capital N, for newtons. Or if you prefer to have your entire unit, you can do that kilograms meters per second squared. Both are correct. Okay, how about this example problem? A 4 kilogram shot put is thrown with 30 newtons of force. What is its acceleration? Okay, break it out. What do I know? Well, I have 4 kilograms. What type of unit is kilograms? Hopefully you said mass. That's a mass, so I know a mass. Is thrown with 30 newtons of force. So newtons, that tells me it's force, and then also the next word tells me it's force. So F equals 30N. What is its acceleration? Okay, look at my equation sheet. What equation do I have that has an F, an M, and an A? There's my triangle for it to set up. This time I don't know my A, so we'll cover that up. Okay, and then let's just take a minute here and think about units. What kind of unit should I expect at the end of my problem if I'm calculating acceleration? What kind of unit is for acceleration? Okay, hopefully you guys said meters per second squared, because that is the unit that you need for acceleration. All right, let's plug this in now. So my triangle tells me that I need to take my F and divide it by my M. So plug in my numbers. My F is 30, my M is 4, and so I just pop that in my calculator. 30 divided by 4 is 7.5 meters per second squared. Okay. If you are following your units, then you would not want to write the Newton here. You would want to write out the full, which is kilograms meter per second squared. And since we're doing kilogram divided by kilogram, the kilograms would cancel off, and we would be left with just the meters per second squared. Okay. Next, let's talk about gravity, because gravity is going to affect all objects on Earth. So gravity is the force of attraction between any two objects in the universe. Gravity increases as mass increases. Gravity increases as distance decreases. So as two objects come closer together, gravity increases between them. Okay, so let's look at an example. In this example, we have two people. We have a politician down on the surface of the planet, and we have an astronaut up in space. Who experiences more gravity, the astronaut or the politician? Here, the politician has less distance between the Earth and himself, while the astronaut has greater distance, so the politician experiences more gravity. Okay, second example that popped up here, we have the astronaut in between the Earth and the moon. So who is going to exert more gravity on the astronaut? Is the Earth going to exert more gravity, or is the moon going to exert more gravity on the astronaut? The Earth is going to exert more gravity on the astronaut because the Earth has more mass than the moon. So it has a greater gravity pull. So then we can get this equation, which is weight. Weight is the force of gravity on an object. So go ahead and add this to your equation sheet. Capital W equals mg. The capital W stands for weight. This is the force of gravity on the object, so it's going to be measured in newtons. It's a type of force. Mass, going to have kilograms again. And G is acceleration due to gravity. So G basically stands for gravity. This is the acceleration due to gravity. So it's acceleration meters per second. So if we look at this, this is kind of the exact same equation, right? It's force equals mass times acceleration. Here, though, the force is going to be thought of as a weight, and the acceleration is going to be due to gravity. So this is essentially the same equation, but it's going to be used with different examples. Okay, now on Earth, here's a constant for you. Make sure you write this on your equation sheet. On Earth, G is always 9.8 meters per second squared. Okay, so the G in this equation on Earth is always 9.8. Now, in some example problems, you'll have a different G because you may be on a different planet. But if it's on Earth, an example on Earth, then your G will be 9.8. Okay? And this is the difference between something's mass and something's weight. Mass in kilograms is always the same. It doesn't change, no matter where you are in the universe. Your mass is the same. But your weight changes because your weight depends on gravity. So your weight on Earth is different than your weight on the moon or your weight on Mars. So, would you weigh more on Earth or on Jupiter? And I have an example of those two planets here. What do you think? You would weigh more on Jupiter. Why would you weigh more on Jupiter? because Jupiter has a greater mass than Earth, which means that Jupiter would exert a greater gravity force on you, meaning you would weigh more because of that greater gravitational force acting on you. Okay, so let's do an example problem. So if Jim weighs 557 newtons, what is his mass? Okay, let's break it up. What do we know? What do we need to know? So we have his weight, 557 newtons. So we have the force that he exerts on the planet. What is his mass is what I don't know. That's what I need to know. Okay, what am I missing here? I only have 2 things, but I need 3 for an equation. What am I missing? Hopefully you guys thought of G for gravity, 9.8 meters per second squared, because he's on Earth. Okay? All right, take a look at my triangle. Force equals mass times acceleration. We can replace that F with the W and that A with a G to get our W equals mg equation. My mass is my unknown, so let's go ahead and cover that one up. So I need to do my force, or my weight, divided by my acceleration, which is due to gravity in this problem. Okay, so just plug in those numbers. I need to do 557 divided by 9.8. And so 56.8 kilograms. Okay, if you're keeping up with units, remember newtons is kilograms meters per second squared. Since we were doing meters per second squared divided by meters per second squared, both of those will cancel off, and you're left with just kilograms. All right, if you do not understand what's going on, or you are lost, or you did not get the same answers when you calculated along with me, please get into contact with me so I can help you out, because up next is your independent practice.